Graphical data representation is another way to analysis numerical data in Statistic. There are many different types of graphic that can be used to represent the data, including pie chart, histogram, line graph and bar graph. So, what is the misconception here? This video will highlight some of misconceptions in statistical data representation. The bar chart and histogram. Cooper and Shaw in 2010 describes bar chart as an illustrator that describes the numerical data where the height of the bar corresponds to the magnitude of corresponding value. Histogram is a specific type of bar chart that combines the continuous data that using range as the categories. Bar graph and histogram are common data display used to represent statistical data collected. The first misconception to be discussed is that students often unable to identify the differences between bar chart and histogram. Both graphs employ bar as representation, however the role of the bar is differing for each type of graph. Students need to know the concept and difference behind both type of graph so that they will not get confused. More example for each type of graph might help student to overcome this misunderstanding. Second, students unable to identify the type of data to be represented using graphical data representation. This misunderstanding will influence the selection of graph types used to represent the data by students. Teacher need to highlight the characteristic of different type of data such as the continuous data, discrete data, and categorical data. Lastly, the student confused on the labeling of the axes as they do not understand the question given to them. To solve all misconceptions mentioned, more explanation, examples and exercise need to be done. One of the possible solutions to solve the first misconception is to highlight the differences between the bar chart and the histogram. First of all, the differences between both graphs are by definition. Bar graph is a pictorial representation of data that uses bars to compare different categories of data. Meanwhile, the histogram refers to a graphical representation that displays data by way of bars to show the frequency of numerical data. Next, bar graph indicates the comparison of the discrete variables while histogram indicates the distribution of non-discrete variable or also known as continuous variable. This different type of variables will be explained more in the second solution of misconception. The bars of both graph also in different mode. In bar graph, bars do not touch each other, hence there are spaces between bars. In other hand, bars touch each other, hence there are no spaces between bars in histogram. The bar graph represents categorical data where the elements are taken as individual entities. The histogram represents the quantitative data where elements are grouped together, so that they are considered as ranges. Here are some of example. For the bar graph, we have excuses for being late to class graph and the mode of transportation to school graph. As for histogram, we have theme park admissions fees graph, customer waiting time graph, and distribution of salary graph. We move on to the second solution for the second misconception, to highlight the characteristic of different type of data. I will only explain three types of data, which are continuous data, discrete data and categorical data. The continuous data is a data that can be measured where the values within the selected range. One of example continuous data is the measure of temperature. Can you name other? How about the measurement of the height or weight of person? The measurement of tree trunk? The discrete data is the data that can be counted and the value is not in a range format. For example, number of people spending money for a specific item. Other things that can be classified as discrete data are the number of balloons, number of fruit on the tree, or the number of leaves on the branch of a tree. Lastly, the categorical data. The categorical data, in other hand, is types of data which can be divided into groups. This include race, sex and educational level. Eye color also can be categorical data. The data can be discrete data or continuous data. If the continuous data was categorized into a group, it will be a discrete data. For instance, if you create a new variable that is coded as short for a hike whose distance is less than 2 miles, medium for a hike whose distance is at least 2 but not more than 4 miles, and long for a hike whose distance is at least 4 miles. Last but not least, the labeling of axis of the graph. Remember at the early part of the video, I mentioned about the students are confused on the labeling of the axis as they do not understand the question given to them. When the student is not able to classify the type of data to be represent, they will confuse about what is the type of graphical representation should be used and what to be labeled on the axis. The teachers should expose the student with a variety of situations so that they will understand more on how to choose which variable should be used to label the axis of the graph. Here is an example. From the book Day Hikes in San Luis Obispo County by Robert Stone gives information on 72 different hikes that one can take in the county. For each of the 72 hikes, Stone reports the distance of the hike, in miles, the anticipated hiking time, in minutes, the elevation gain, in feet, and the region of the county in which the hike can be found, North County, South County, Morro Bay, and so on for a total of 8 regions. From the situation, we have 5 different variables: number of hikes, the distance of the hike, in miles, the anticipated hiking time, in minutes, the elevation gain, in feet, and region of the county in which the hike can be found. Before we continue with labeling, the student should know what to be labeled on x-axis and y-axis. X-axis is labeled with independent variable whose value do not depend on other, while y-axis is labeled with dependent variable whose value are depend on other variable. Among the variables listed, only number of hikes is the dependent variable, so it is the label of the y-axis. For the rest, it will be on the x-axis. Here is the example how you should label your graph. Why don't you try it yourself using given situation below? Good luck then.